Every single day, our solar system is moving through the galaxy at 828,000 kilometers per hour. For billions of years, nothing came back the other way. Then, in 2017, something did. Then again in 2019. And now, in 2025, something is coming toward us right now. Something older than the Earth itself. And this time, we saw it coming. What is coming for our solar system? Here's something that should bother you. For the entire history of human astronomy, thousands of years of watching the sky, we never once detected an object from outside our solar system. Not one. Then, in October 2017, a telescope in Hawaii caught a faint blip of light moving at an impossible speed. By the time anyone realized what it was already leaving. We had days to study it, maybe less. We called it Oumuamua, the Scout. 2 years later, an amateur astronomer in Crimea spotted a second one, Borisov, also already past its closest point, also already going. 2 strangers from the galaxy, both gone before we could really look. Scientists started asking a question nobody had considered before. How many of these things are out there, and how many have we already missed? The answer, it turns out, was uncomfortable. Let's talk about Oumuamua. Because without understanding it, you can't understand why 3I/Atlas matters so much. Oumuamua didn't just come from another star. It behaved like nothing we had ever seen. When it swung around our sun, it accelerated. Not slowed down, accelerated. Physics says that's impossible for a rock. Gravity pulls you in, not pushes you out. The only way an object speeds up near the sun is if something is pushing it. Comets do this naturally. As they approach the sun, their ice turns to gas and shoots out like a thruster. But Oumuamua had no tail, no gas cloud, no visible outgassing of any kind. It pushed itself with nothing we could see. That single fact has never been fully explained. The leading scientific theory today, a shard of frozen nitrogen, essentially a broken piece of a distant Pluto, fits most of the data, but not all of it. The shape was wrong, too flat, too reflective, tumbling in a way that felt almost deliberate. One Harvard astrophysicist put it plainly, the simplest explanation that fits all the data is an artificial object, a light sail, a probe. He wasn't joking. He wrote a book about it. And the reason that idea hasn't been fully dismissed, even by scientists who disagree, is that nobody has a better answer. On July 1st, 2025, an automated telescope system called ATLAS, designed to catch asteroids before they hit Earth, flagged something unusual. An object, moving fast, coming in on a hyperbolic trajectory, too fast for the sun to capture, coming from outside. Another interstellar visitor. But this time, crucially, historically, it was still on its way in. 4.5 astronomical units from the sun, just past Jupiter, months away from its closest approach. For the first time in human history, we had advance warning. We could watch it come. Here's what makes 3I/Atlas different from the first 2 visitors. Oumuamua and Borisov both came from the thin disk of our galaxy, the flat spiral layer where most stars live, where our sun lives, where most planets and comets and everything familiar originates. Atlas came from somewhere else entirely. Its trajectory traces back to the thick disk, a much older, much thinner region of the galaxy above and below the main plane. Fewer stars, less activity. Objects there aren't newly formed. They're ancient leftovers from the galaxy's early years. How ancient? On the high end of current estimates, more than 7 billion years old. Our entire solar system is 4.6 billion years old. This object was already billions of years into its journey before the Earth existed, before the Sun existed. It has been traveling through the void of interstellar space since before our star was born, and it is arriving now, in our lifetime, in our solar system, in our sky. Let's talk about size. because the numbers here are worth sitting with. Oumuamua, roughly 100 meters across, the size of a skyscraper lying on its side. Borisov, around 2 kilometers, roughly the size of a small city. 3I/Atlas. Preliminary measurements put the solid nucleus at up to 11 kilometers in diameter, surrounded by a coma, a cloud of gas and dust, stretching 20 kilometers wide. For reference, the asteroid that ended the dinosaurs was approximately 10 to 12 kilometers across. Each interstellar visitor we've seen has been larger than the last. That's almost certainly a coincidence. Our detection technology is improving, so we naturally spot bigger objects. Almost certainly. Oumuamua flew past Earth at 24 million kilometers. Close enough to detect, too far to study properly. 3. I/Atlas isn't flying past one planet. It's doing a tour. Because it's coming in from the side rather than head-on, its path carries it past multiple worlds. Mars, 28 million kilometers. Venus, 97 million. Jupiter, on the way out, 53 million. No known interstellar object has ever had a trajectory like this. And Earth? Earth will be on the opposite side of the Sun during Atlas's closest solar approach. Our telescopes will lose sight of it entirely in October. We won't see it again until December, after it's already made its closest pass and is heading back out to interstellar space. Draw your own conclusions about what it means that the one inhabited planet in the system gets blocked from view at the exact moment of closest approach. Probably nothing. Here's the part of this story that almost nobody is talking about. We have spacecraft already out there. Right now there are active orbiters around Mars. There is a spacecraft called Juno in orbit around Jupiter. Both of them, under the right circumstances, could potentially be redirected to observe 3I/Atlas at close range. The Juno scenario is particularly interesting. According to some preliminary orbital calculations, Juno could potentially depart Jupiter's orbit and intercept Atlas in deep space sometime in early 2026, as the object is heading back out of the solar system. This has not been approved, may never be approved. The spacecraft wasn't designed for this. The fuel margins are tight, but the window exists. For Oumuamua, there was no window. We never had a chance. We watched it go and we argued about it for years with no new data. This time, we could get a photograph, a spectrum reading, a close-up. We could actually know. Step back for a moment. Before 2017, the count of detected interstellar objects passing through our solar system was 0. 0. For the entire history of human observation. Then, 3 in 8 years. The standard explanation is simple. Our telescopes got better. We can now detect objects we previously would have missed. The rate was always this high, we just couldn't see it. That's almost certainly true. But here's the other way to think about it. Our solar system is an incredibly small target. The distances between star systems are so vast that the odds of any random object hitting our specific patch of space are extraordinarily low. Unless there are far more of these objects than anyone expected, or unless some of them aren't random. In October, Atlas disappears behind the Sun. In December, it comes back into view, already past its closest point, already accelerating away. And that moment will answer the one question that has haunted astronomers since 2017. Will it accelerate unexpectedly, the way Oumuamua did, with no visible explanation? Or will it behave like a normal comet, predictable and understood? If it accelerates, we are back where we started. Another unexplained object, another open case. If it doesn't, we learn something real about what these things are made of, where they come from, and how the galaxy moves objects across billions of light years of nothing. Either answer changes how we understand the universe. We just have to wait. 3 objects, 8 years. Each one bigger and stranger than the last. If you want to know what happened when Voyager 1 went silent in 2023, what India actually found at the moon's south pole, and why Pluto might be the key to all of this, it's all on the channel. See you on the next one.